Welcome to this video. Considering the recent surge of research in the field of COVID-19, a model has been prepared which will describe the dynamics of infectious disease. In this video we will see how the disease spread actually happens. But first let us look at some statistics. This is our Excel model. When you click in the icon, data is downloaded automatically from European Center for Disease Prevention and Control Registry and populated in this table. The data is segmented in form of columns, date, number of cases, number of deaths per country. Let's see how the data actually in sheet, total cases and deaths are sorted. As you select the country from drop-down, the charts are populated with data. The blue line stands for total cases, and red line stands for number of deaths. Now let's go to our pandemic disease mathematical models can help shed light on the evolution of the coronavirus pandemic. The next trend in epidemic data science will be to issue prediction models that focus on early detection. Medical professionals and researchers have developed a series of modeling techniques to describe the spread of infectious disease. In this model we will see how the SIR model works to predict the spread. S means susceptible to become infected, I means infected through contact, and R means recovered or no longer sick or developed immunity against infection. Through time a person may move from being susceptible to infected to recovered, so the number of people in each condition changes, but the total of S plus I plus R remains constant. N represents the entire population and is identified as a closed system. This is a steady-state model with no one dying or being born to change the total. The number of susceptible people today equals to the number yesterday, minus the percentage of people who become infected today, times their rate of infection, and times how many people were infected yesterday. As long as the disease is spreading, the number not yet infected minus the remaining susceptibles decreases every day. The number who become infected today equal yesterday's number of susceptibles times the rate of infection, but it may seem odd that we multiply that result by how many were infected yesterday. The reason is that the rate of infection rate is not proper. Three parameters determine how fast and how many people move from category to category: infection rate, recovery rate and death rate. The x-axis plots time, specifically the number of days since beginning of the outbreak. The y-axis plots the number of people in each category. The rapid decline in blue line means the number of people who have not been infected are very susceptible. The red line means the daily number of infected people. It goes up to a maximum, and FLLS slowly means everyone nearly has recovered. The green line means the number of people recovered and removed from the simulation because they have developed immunity against the disease. So what about the rest people? They have died, which we will discuss in our next model, which is called the CIRC model. To know more about this model you can email at banik508@gmail.com. Don't forget to like this video and share this with your friends.